Hi everyone. My name's James Cash. I'm super excited. Oh no, I touched the HDMI cable. I've made a huge mistake. Okay, don't do that. Super happy to be here at the Clojure North. It's quite an honor to have the final talk of the day as well. So I know all the people that are here, despite the fact that it's Easter and Passover and 420, and for our visitors, 420 in a country where weed is legal. The fact that you're here is very special to me. So the talk I am going to do today is maybe a little bit different than some of the other talks here. A lot of people have been talking about kind of the very nice, elegant things you can do with Clojure, how we can have the beauty of functional programming, these mathematical abstractions. But me being kind of the iconoclast that I am, I'm going to talk a bit about the opposite, about times when things got real bad and I had to do some kind of gross things to make things work. So I know that it is legally required that I have a definition here. So a Tauntaun, for people that don't remember Star Wars, that's the weird creature they ride around in Empire Strikes Back on the ice planet. And so maybe spoiler alert for Empire Strikes Back. So Clojure, a lot of the times it's real great. A lot of the times it's our mighty steed that we can ride around, accomplish the tasks that we need to. It's not always the most elegant kind of thing, but it works very well for its purpose. It has a way it wants to work. If you can go along with that, things are great. Sometimes, though, things don't go exactly the way Clojure wants. And sometimes you need to use that Tauntaun in a way that it didn't really want you to use it. By the way, that scene in the movie is real short. I was going to put it on the slide, and I realized when you actually see it just in a big picture and it's just staying there, it's real gross. So I spared everyone that particular screenshot. So the first thing I'm going to talk about, the first terrible mistake I made, I'm going to call our Clojure script confusion. So what I was doing here, we had a system. For various reasons, we were generating Clojure script at runtime and then dynamically compiling it. So not only were we invoking CLJS build at runtime, the actual code that we were passing to CLJS build, we were dynamically creating it as well. So a bit of background. The idea here, at the time we were building a bunch of kind of marketing style websites. I'm sure you've all seen, hero image, title, bar at top, and then you scroll down, there's a bunch of kind of colored bars with, 3 people standing and smiling. It says the mission, feature, that kind of thing. We're building a lot of these. We want some way to make it a little bit easier for us. So we built a kind of templating system in Clojure, of course, where we realized there was a lot of kind of common elements that we would reuse between a lot of these sites with just some variations. So we built this kind of templating system. So we have like a hiccup looking thing under template that's like our HTML. We have some garden looking stuff that we have under style to generate our CSS. And then we have a script thing where we have some Clojure script looking stuff that we use to generate the Clojure script that's going to be on the final page. The difference between these other things, which is not super important, but just to note, we have this block var thing, and this is how we had kind of inheritance of templates. So this would be kind of an abstract template that says this is kind of the general setup, and then one of the kind of final levels of templates that actually was using it would inherit from this and just say, okay, logo link is this, and the block class will be used to inject styles and such. So this is what we were doing. We were building this thing. Seemed to work pretty well, at least the generating the hiccup and the garden stuff was working pretty well. I was having a lot of fun because we're basically building a compiler. I wrote a monad to do some math and CSS. I was feeling real proud of myself. But then we got to this point where we're generating the JavaScript, so we combine all the little snippets of Clojure script from all the different places. We combine it all together, we fill in all these variable things, we run it through CLJS build, and outputs a bunch of JavaScript that looks reasonable. It's a big pile of advanced compilation JavaScript. It seems like what it should look like. But when we tried to run it, basically everything was undefined. It's trying to call cljs.core conj or whatever, and it says, oh, that's undefined. Like, what? What's going on? Like, all our variables were undefined. The core library functions that I was trying to call into were undefined. And so at this point, what do I even do at this point? I can see the stuff I'm feeding into the compiler. I can look at that. That seems reasonable. The stuff that's coming out seems reasonable to look at it. But clearly there's something's happening inside the compiler that I can't really see into, and that's clearly where things are going wrong for me. And so how do I deal with this? If this was a lot of other languages, if I was, generating Python, or I'm generating whatever other language at runtime, how do I look into this? Do I have to fork the compiler, figure out how all this stuff works, change my entire tool chain to use another version of it? It's going to be really tough if I want to actually start instrumenting the library. But luckily for us, Clojure and ClojureScript, they're not self-hosted. The core language itself is just a library. In some ways, people can maybe have aesthetic objections to this. It would be real nice if this was a self-hosted thing, if it could run by itself. But while it's not, let's take advantage of it. So the fact that we think of ClojureScript as this language that we're writing in, but really it's just another jar that LineEngine is including in our class path for us. So if I want to debug something that's happening in the core library, nowadays I would probably use something like Cider to put breakpoints in. At the time, I went for the brute force approach, which is I cloned ClojureScript, I put a bunch of print lines in it, and it's just a LineEngine project. I can just make a new version, run line install. I have my own local bespoke version of ClojureScript with a bunch of extra debugging information in it, and I can just run my app with that. I just managed to instrument the core compiler of the library to do this admittedly kind of crazy thing I was doing, but it just worked, and it was real simple. And so I was able to find out that the problem was arguably my fault. Anyone that's been doing Clojure for a while, if you see the code, you'd probably be able to guess where the issue was. The issue was essentially we were doing a map over some code, and I wasn't forcing the map. So the solution, I don't know how well the diff kind of shows up on this screen, but at a map, I just need to put a do wall around that map. I like this diff because I think this is maybe the highest ratio of amount of time it took me to figure out what was going on to how small the solution was. At least a week, days and days, hours of me just, what is going on? It's getting code, but nothing's defined. What's happening? It's oh, you're missing 5 characters. Oops. So what I think was happening, this was a while ago. I tried to actually reproduce this recently, and I couldn't because I think it was kind of a confluence of various versions of things at the time. So what was happening was the ClojureScript library, the CLJS compiler, gets the code, and then it's kind of walking over the code. And while it's doing that, it's changing some state to say, hey, here's a variable reference that we're going to need to link up in the output of JavaScript. Here's another one. Here's another one. So it would do this walk, and then based on that mutated thing, output what the mapping of variables was. But because it was lazy, that hadn't happened yet. It had said, okay, do this transformation, and the lazy sequence says, yeah, sure, I'll do that eventually, not right now. But then it had already tried to output the variables. Something later came out and actually forced the code, so my outputted code looked reasonable, but it was too late for it to actually connect to there. I'm sure some of the speakers here that actually know how the ClojureScript internals could probably give that in more detail after people are interested. So the thing that I took away from this, it may be kind of trite, but having your language as a library is really useful. This is a thing that I never really thought about a lot of other languages this way that I do with Clojure all the time. How many times have people looked in the source of, I said Python before, Python or Ruby or JavaScript or any other language? How many times have you looked into the implementation of the language and fiddled around with versions to fix a problem? Because I don't know, I haven't done that. But the way Clojure and ClojureScript are architected, I find it actually makes it really easy to just selectively play around with the language itself. So I didn't learn my lesson. So there's another time I was doing some weird stuff with generating ClojureScript at runtime. So this time, I wasn't generating the ClojureScript itself. I had some pre-written things. But what we were doing was compiling the ClojureScript at runtime. So at this point, this was a different project where it was a React-based ClojureScript thing. So at the time, probably Ohm, I think. But a bunch of different pages, like a multi-page app thing written in Ohm, and we wanted to be able to optimize it by pre-compiling a bunch of pages. I think there's better ways of doing this now. At the time, this is how we did it. We had in Clojure side, we'd pre-compile the page, passing in the information for the route, and then cache that generated HTML and JavaScript. So we wrote this system. It worked fine in development. Everything was looking good. But when we deployed it, it couldn't find externs. So the code was working. Everything worked fine in development. We push it into prod, and now it can't find externs. So now all the parts of the thing that interacted with React broke. So what was going on? So the important bit of information to solve this mystery was that in production, for this particular thing, we weren't running it just as a normal Uber jar, the way we typically do it. Instead, for various reasons, we were using a mutant to deploy this. So if people aren't familiar, a mutant's a Clojure web manager thingy based on JBoss. We were using it both to serve apps and because we needed some other things. We needed, I think, background tasks at the time. And while I'm up on stage, I do just want to mention that the mutant community was incredibly helpful while we were had this problem and doing other stuff with them. They went to the step of tracking me down on Twitter because I appeared on the IRC, asked a question, but then had to disconnect or something, and they saw my username, tracked me down, and said, hey, were you the guy on IRC the other day? I think we have a solution to your problem. So that level of community support, I thought, just deserved a shout out. So what was going on here? Doesn't work under a mutant. So at this point, I'm already used to, well, I'm just going to go look inside ClojureScript itself to try to figure out what's going on. And so tracing the path of what's happening, we started this function. So this is what was happening when it was trying to look up an externs file. So it gives a path for some JavaScript stuff. It gets all class path URLs, and then does a bunch of other stuff that I'm going to assume worked fine. So I dig a little deeper into all class path URLs, and I find this. So whatever, bunch of stuff, the salient point here is that it gets all class loaders, and then it's filtering out just the things that are subclasses of java.net.url class loader. And here's the problem, is that a mutant's class loader isn't a subclass of java.net.url class loader. So a mutant has a perfectly cromulent class loader, but ClojureScript just says, no, I'm not going to use that. So at this point, this is, I think, arguably a bug in ClojureScript. There's no reason why this shouldn't work to load something. We should be able to just change ClojureScript to not have this unnecessary restriction. So I get on the ClojureScript Jira, email physically mail the contributor agreement, whatever, do all this stuff. There's some back and forth. The Dynapath author comes in and says, hey, this is actually exactly what Dynapath is for. This could solve the problem. ClojureScript says, yeah, this looks nice, but we're not going to pull in a dependency just for something like this, which, fair enough. And eventually, I'm kind of like, can't we just do this? All that logic there, this is essentially what it's doing. It's saying, get this out of resources, whoever that may be, and then it needs to be a vector for whatever reason. But say, well, can we leverage like clojure.java.io? Presumably that's okay to use. So I submit this patch. I think, well, this fixes the problem. It doesn't seem to change anything else. I'm just using the built-in functionality. So it should be good. I've solved my problem. But, and there's another complication. I don't know how legible this is, but what this is the screenshot from the Jira thread where I say, hey, I have a patch, it fixes this problem. And then Dave Nolan says, okay, cool, thanks. Can other people say whether this works for them? And then a year and a half later, when no one else has responded, he says, okay, well, this has never been followed up on, I'm going to close it. So this is kind of disappointing. I didn't get my code in. On the other hand, I do feel a little bit of the kind of perverse pride that I found a compiler bug, and it was so obscure that literally no one else ran into it to even say that this fix worked for them. So didn't get my code in, but I can still be a proud iconoclast just doing ridiculous things. Okay, but how did I fix my code? Because I still needed this fix for my thing to work in production. And even if this patch didn't get accepted, what did I do for the year and a half while we waited for this to come in? So I didn't really want to run like a forked version of Clojure script with this tiny change or whatever. So I reached to the next best thing, one of the great tools for messing with code that you didn't write. That's using with redefs. So with redefs is one of these great, really, really kind of sharp tools where for people that are not familiar with it, essentially what it does is let you opt in to lexical scoping. So a little explanation for what this means, what the distinction is. So generally speaking, we're going to say we have like lexical scoping versus dynamic scoping. And kind of the quick way of describing it is lexical scoping means the scope of variables is based on how you read the code. And dynamic scoping is scope is based on how the code is being run. So my understanding is that like a lot of older languages use dynamic scoping because if you're implementing environments, it's very easy to implement dynamic scoping. And so to get a somewhat apples to apples comparison, Emacs Lisp is dynamically scoped. It has ways now of opting into lexical scoping, but this is if we don't use that. So we can see we have two code snippets that we can see are basically the same, just kind of def is pronounced setq instead. So we can see in Clojure, if we have some value and then we have a function that inside of it refers to the value outside of it, well, if we call that function, it's always going to give the value based on where we wrote it. It would seem kind of madness if it didn't do that. But that's exactly what happens in, for example, Emacs Lisp. So we can see here we have our defin to define a function. It's referring to x, which lives outside of it. But we see here if we just say, okay, well, I'm going to locally bind x to be some other value, then in Emacs Lisp, if we call bar, it gets that new value of x. So you don't really want this in general. As you can imagine, this can make stuff just incredibly fragile and just really complicated. And I think that's kind of why a lot of classic Emacs Lisp is kind of nightmarish. But sometimes this is super convenient. For example, if you want to rebind standard output, standard error when you're calling some stuff, it's nice to be able to say, okay, output is now this string builder or output stream or whatever you want, and then call your function and know that all the transitive calls of that function are seeing the new value. And so that's exactly what with redefs gives us the ability to say, hey, I want anything that is transitively called inside of here to see this new value for this old var. So what I was able to do in this particular case was say, okay, well, I'm just calling cljsc build, but I know like way down deep in its guts, it's eventually calling this all class path URLs, and I can use with redefs to just say, hey, don't actually call that version, call this other version of our function, and then I can just do this and it works, this one line that doesn't affect everything else in our system. So we probably don't want dynamic scoping by default, but it is a really nice hack. When you have someone else's code that you need to fix, this is just such an invaluable tool to have. I did something very similar to this just the other day. I was playing around with the library to just experiment, see if it could work for what we needed it to do. And I realized like some transitive call into a utility function it was making a couple levels down. I wanted to pass a couple extra parameters to it. I needed to slightly change what its behavior was. And I didn't want to like copy all the layers of implementation above it just to change that one thing. Using something like with readefs, I was able to just make my own local version of that deeply nested utility function, swizzle it around a bit, and then use with readefs at the top level to say, hey, any transitive callers of this function actually call my version of it. So don't want this all the time, but really, really useful, when you're in a pinch. So the last tale that I bring everyone has to do with transit. So this is actually related to something Raf talked about yesterday in his lightning talk, where he brought up Braid. Raf and I worked together. So one of the things that this chat system we talked about in composing applications, one of the many things it does is what we call bots, which are essentially just webhooks. You can say, when these certain things happen in this chat room, send a notification to this configurable webhook, configure what events, it can send responses back, bunch of stuff, whatever. So we use transit to communicate with these external things because we want our nice, rich Clojure data structures. We don't want to have to use kind of something else like JSON, some other thing that doesn't have all the nice expressive power that we would miss from EDN. And because this was supposed to be, hopefully just going fast, going to other things, and because I'm a masochist, I decided to do this as transit plus message pack. So instead of going down to message pack or to JSON, it would go to message pack. Can I see a quick show of hands? How many people here know what transit does, what the idea of transit is? Okay, most people. So for those of you that don't, the idea of transit is that it would be really nice to be able to just send EDN over the wire, just to send Clojure data with our nice maps and sets and vectors that are different from the JavaScript things, like keywords, UUIDs, all these nice things. It's really nice to be able to just send that over the wire. The problem is marshalling and unmarshalling that stuff can be quite slow. So the idea of transit is that, well, the same way that Clojure is not self-hosted, Clojure says, hey, let's just use all that underlying infrastructure, the JVM, to make our stuff fast. The idea with transit is all these languages have underlying implementations for parsing JSON and message pack. Let's use that and then just add a little bit of kind of metadata on top of it. So the idea is that you can kind of do a very simple, high-level transformation of whatever to JSON, and then the place where it's receiving it can use its high-performance JSON parser to convert that data into structured JSON, and then you can just do some very simple little transformations to turn it back into the equivalent Clojure data. So the other thing that I did here, because I like to make life hard for myself, was kind of as a proof of concept that this is, can be an open, extensible system, was a lot of these integrations were written in different languages. I think actually none of them are Clojure. So we had some that were in Rust, some that were in Elixir, I think Haskell one, a bunch that were in Racket. So a bunch of other languages, and none of these languages had transit implementations. So what I would do, I'd use the underlying message pack library, and then it's a little, just simple little hop, skip, and a jump from there to that is turned into our structured data, convert that into the equivalent of the rich transit data structures. So this was working for a while. It seemed to work fine. So this is kind of the idea. So we have some Clojure data, we have a vector of maps, and mean, here, this is almost like JSON, but the fact that those are keywords and not strings, there's a difference, right? If I wanted a string, I'd use a string. That's a keyword. So in transit via JSON, which I'm going to be using in these examples because no one wants to read a message back on a slide, we translate it in this way. So quite straightforward. As you can see, the only difference is that the things that would be keywords in Clojure have the little tilde colon in the JavaScript string. So then when we parse that out, if we see a string that starts with tilde colon, we can turn that into a keyword instead of leaving it as a plain string. So this was working for a while, my kind of hand-rolled transit parser on top of things. But I was seeing some weird things. Like some of these integrations would kind of occasionally die, and I wasn't really sure why. Actually, the Haskell one was, I think, the least reliable because it would just die and give no messages and no indication of what happened because, I don't know, strong typing. And so it wasn't until I started working on the implementation, again, of this thing in Prolog that I realized what was going on. So what was happening is I was running into this thing called transit write caching. I think that this was introduced later, or just it never came up when I was originally doing this stuff, was what transit can do here in order to optimize sending a lot of data over the wire. Instead of repeating all these keywords and stuff, things that are going to be equivalent, we can cache them. So what's going on here is we can see, well, essentially what's happening is when it's going over this, there's certain things that are eligible for caching. In this case, we're really just going to care about keywords. I think it's specifically keywords that are the keys in maps. When the transit system is turning this into JSON, the first time it sees one of these things that's eligible for caching, it says, okay, ID, we can cache that. This is the first time I've seen it, so I'm just going to emit it. So we can see there, it emits the tilde colon ID in the JSON, but it remembers, okay, the first thing I saw was ID. It does the same thing for val. It says, okay, well, the next thing I saw was val. I'm going to omit it, but I'm going to remember that was the second cacheable thing I saw. And the next time it has to emit ID, it says, oh, I've already emitted that. I can just emit the index into the cache and do that. So I didn't realize that this was happening. Again, I was trying to figure out if this changed in transit because I had zero recollection of this being mentioned when I originally wrote these things. I think maybe just the data we were sending didn't hit this at the time. But I realized this after I already had all these things written. And so what do I have to do? Well, I have to now go back to that Haskell code and that Rust code that I wrote like a year ago. So even just getting that to compile is going to be tricky. All these other things, I need to now change all of this to be aware of this caching stuff. But also, a lot of these parsers, these things that were handling that translation from the data to transit, they were working at this like a kind of a higher level representation, where they're based on this message pack library. It's already converted it into something structured, and then I'm doing some transformations on top. So for example, the way the Rust thing was set up, there's this very nice library called a Surde, where you just give a struct and you say, this is encodable and decodable. And then I can just get a bunch of bytes and say, hey, Surde, this JSON can turn into this struct, so do it for me. And just whoop, populates my struct with all the appropriate keys from the JSON. Okay, that's nice. But that means that I don't actually know what order the keys were encountered in. Similarly for other things, where it parses things into like hash maps, turn the maps into unordered collections. So if I want to do this post-processing step to fix the write caching, this is going to be real tough because I'm essentially going to have to go down to that lower level message pack code, completely change the way I do parsing to be this much more stateful thing. But that's what I have to do, right? Could I do something terrible instead? Because I am lazy. Okay, well, the first thing is, can I just turn write caching off? Is this just a knob I can twiddle on transit? So I start investigating, and I think, even if it doesn't let me, I have with redefs, I can slice up that transit CLJ to make it do what I want. But then I'll look at the implementation of transit CLJ, and I realize, oh, that just calls into transit Java. And deep in the guts of transit Java, I see this. So details here, not super important. The idea is that it makes a final write cache, so it's unmodifiable because it's closed over in this inner class because Java. The important thing here is that for message pack, I have no ability to pass any kind of configuration thing to this cache. I can't give it a different cache. I can't say, I would really like you not to cache things. I can't say, just trust me, there's not a lot of data. I don't have a lot of repeated keys. It's fine, please don't do this. I cannot do this. This thing is out of my hands. I can't even use with redefs now. What am I gonna do? So our quote unquote solution, because the real solution is to fix my code, but no one's got time for that. I'm just going to make my own write cache, insert, Bender thing. In any case, so able to use this very nice little Java interop fiddly thing, the proxy. I think this is like the only time I've used proxy. I've used Reify a whole bunch. This, I'm still not entirely clear on exactly what the semantics of this thing are, but what this is doing is saying, hey, this thing, this anonymous thing we're making, it's a write cache. And I can just provide implementations to say nothing is cacheable, and to write something from the cache, always just write out the initial value. Cool, so I have this fake cache. And then the Java interop. It's not just for using libraries that you wish you didn't have to use. I'm just able to use the import all the transit Java, and then essentially just re-implement what that Java code was doing in Java interop, and just pass in my fake write cache instead. And now every time I want to make a writer, instead of calling com.cognitec/writer, I call my non-caching writer, and now I have tricked the system into doing what I want, not what it wants to do. So the takeaway here is somewhat analogous to the with redefs thing. When even that fails you, when it's down to the substrate of Java, the Java interop, it's really powerful. Like when I first encountered it, I kind of was under the impression, it's just for interacting with libraries that are in Java. I need to call .index of on a vector for some reason. But it's super useful for doing things like this, just making up your own fake objects and injecting them. And it's proven to be a really powerful way for us to kind of get Clojure script or Clojure code down to the guts of something that didn't expect it to be there. So there's another thing we had to do a while ago when we were hacking around. You can tell this a long time ago because this was when we used less CSS. Does anyone remember that? Where we were hacking around with the line less CSS plugin. We wanted to do an auto build thing instead of just running a one-off thing. And the underlying engine that it was using in the library wasn't doing the things we wanted it to do. So we're able to use Java interop, make a fake resource loader that does the extra logic we wanted to, and inject it down to the guts of this Java library. So super useful stuff, not just for using libraries. You can use it to do really quite heinous things if you want to. So I've been using Clojure for, I don't even know, something like 10 years now. I don't want to think about it. I turned 30 this year, and that's a lot of existential dread for me. This doesn't happen a lot in Clojure. For the people that have not used Clojure too much, it's not like this happens all the time. I get these terrifying, just deeply confusing bugs. They only happen once in a while. But I think one thing that really speaks to Clojure's strengths is even when I have these really confusing bugs in other people's code, it's not even, for the most part, in code I wrote. It's errors, things that are working differently in other people's programs. The fact that Clojure's dynamic nature gives us this power to fix bugs, not just in our stuff, but in other people's stuff without them knowing about it, can be a really, really invaluable tool to have. Something that can, just mean the difference between, it's kind of hacky, but I got this to work, and I don't know what we're going to do because this underlying thing that we have to use isn't working. We need to start from scratch. So it can really be a lifesaver. So I hope that you don't need to do these things I've talked about very often. But maybe if you find yourself in one of these terrible situations, you know, a whatever 7-foot tall bug with whatever puts the back of your favorite head up against the wall, or whatever that movie with the guy is, Chinatown. Anyway, I hope that you recall these things and they are of some use to you. So thank you so much for staying past the end of this conference. Does anyone have any questions?
Mm-hmm. And they waited a year and nobody responded. Who were they expecting to respond? And wouldn't it have been possible for you to just go to 7 of your coworkers and say, hey, you know, go to some Gmail accounts and respond that this is your problem as well, and get your things accepted?
So the question was, in that year and a half interregnum where I was waiting for a response on the bug, why didn't I just get a bunch of people to respond and say, oh, it works for me? Honestly, well, one, my coworker is Raph, so we wouldn't have been able to make that large a troll army. And also, honestly, I was already using with redefs at that time because it was taking so long. So, I mean, I didn't really care enough to do it for me. I was hoping that if this was useful for other people and simplifying the code, it would go in. But like, I was kind of just trusting the process and hoping it would happen eventually, I guess. Yes.
Is there anywhere stuff like that is surfaced other than the Jira, the official Jira? Is there a community list of
So the question was, is there any place other than the Jira where things like this are surfaced, some kind of community thing? I'm not sure. Not as far as I know, I guess. Yeah, the Jira is open, but I know it's not the nicest interface to look around. So I guess you can somehow, by clicking on a million menus, find open issues out of whatever. But yeah, not as far as I know. Yep.
So if you were using this approach, or you had this problem today, for example, you have a Clojure application and other application written in different languages, would you still use Transit?
Yes, would I still use Transit?
Give the right answer.
Yeah, I mean, I probably wouldn't have used Transit plus Message Pack because it just was completely unnecessary for the amount of data we were doing, and a lot of things would have been a lot easier just to notice what was happening if it was Transit plus JSON. I think that would have made a lot of things much easier. I think using Transit was still useful because we do send over the channel a lot of things like UUIDs and stuff like that,
There are plenty of other formats that support them.
Sorry?
There are plenty of other formats, serialization formats that support them, right? I mean, what's the value of using Transit if you don't go to Clojure?
Yeah, I think just because it was what was there at the time, and I just thought it would be, honestly, kind of an interesting challenge to write a bunch of Transit
but
parts
back then I
with a bunch of
understand. I'm
languages.
just curious if it's now.
Yeah, I don't have a good reason.
Thank you.
Yeah. Cool. Yeah, well, thank you, everyone.